Hi, today we'll be talking to you about greenhouse gas mitigation strategies in relation to sustainable building materials. Firstly, let's look at how significant this sector is for emissions. Greenhouse gas emissions from the construction sector account for somewhere between 6 to 23% of global emissions, depending on how this figure is calculated. For example, by pure building materials only or the entire supply chain of construction. Building materials, as a subset of the construction sector, are measured using an embodied CO2 metric that captures the life cycle of materials across the entirety of their supply chain. This supply chain includes the extraction of raw materials, transport and logistics, manufacturing of the end product, on-site energy use in construction, and in-situ life cycle of the materials, such as their maintenance and decay. So, often these materials are sent to landfill or incinerated after use, which significantly impairs the state of the environment. Scientists note that in the coming decades, the demand for building materials will only grow. And in this matter, it is important to ensure these materials are environmentally friendly and safe. In this presentation, we look at some innovative building materials that could help mitigate and reduce CO2 emissions from the construction sector. We will also analyse a case study of where these technologies are already being successfully implemented. Next up, we'd like to walk through some technological advances in building material production, and also some ancient techniques that are being reinvented to reduce CO2. Innovation in recycling, upcycling, low-embodied emission materials, and alternative zero-emission construction has been a growing field for many decades. When we talk about construction materials, we're discussing the major materials used in the construction sector, including masonry and all-formed concrete, internal and external wall panelling, for example chipboard and plasterboard, industrial plastics, support structures, for example wood and steel, renders, for example mud and lime-based, roof tiling, wiring, and insulation. We have also selected 3 innovations in low CO2 material technology that are at various stages of development and deployment in the market. These are cement, flooring and roofing, and stabilized mud blocks. The biggest building material used globally and representing 8% of all greenhouse gas emissions, and the second most used resource on the planet behind water, is cement. During the 2016 Paris Agreement, cement was singled out as being a critical part of reducing the footprint of the construction sector. Innovation in cement is revolving around the reduction or replacement of the key ingredient clinker, which accounts for 50% of the CO2 found in cement. A potentially huge win for clinker replacement is the use of fly ash or industrial slag that not only recycles a byproduct of other industrial processes that end up as landfill, but also uses no more new energy in the creation process, as the CO2 has already been considered as part of the original manufacturing process. Large-scale experiments are being conducted in China and India using this cement production process, and it could see a 70 to 90% reduction in clinker use by 2050. Advances in low-carbon systems have seen a wave of retail availability of sustainable flooring and roofing alternatives. These alternatives include asphalt tiles, locally harvested wood joints and flooring, rammed earth flooring, and roof tiles embedded with solar cells for energy creation. These systems, although often 2 to 3 times more expensive than conventional systems, are slowly being taken up in wealthy countries across Europe and North America. Building codes and new building stipulations are also moving to adopt new minimal standards in flooring and roofing systems. The 2010 introduction of the California Green Building Standards Code was the first major rollout of minimal low-carbon building standards which focused on flooring, roofing, and paneling criteria. An alternative to masonry, bricks, and blocks is mud. One of the most sustainable, ancient, and low CO2 building methods, the use of stabilized mud blocks in building foundations is gaining traction, in particular in the rapidly developing Indian construction economy. Stabilized mud blocks mainly replace burnt clay bricks that produce large amounts of CO2 through the burning process. This is compared to stabilized mud block production, which uses rammed earth and dyeing techniques, which helps reduce 60 to 70% less energy. Stabilized mud blocks also have side benefits and indirect savings on emissions, with blocks being made on site using local mud. This method reduces transportation and logistics costs and increases the use of recycled industrial waste such as fly ash and quarry dust. Another way to reduce emissions from the construction sector is simply a better design process, which combined with low ECO2 materials and energy efficient technologies can be very effective. We've chosen a case study that combines all these elements in a residential building, outlined in a recent paper from the University of Colorado that looked into low carbon housing. The paper uses a typical floor plan for a 3-bedroom, 2-bathroom home at elevation in the mountains and compares a standard material build with a low ECO2 material build. The premise of the paper is set up by explaining how the carbon footprint of the house is calculated. The calculation is based on a combination of ECO2 and operational CO2 or OCO2 measurements. Current footprint calculations in green building standards, however, only reward buildings that reduce OCO2, which looks at the energy, water, and ongoing operational running of a building. Stuckenschneider's argument is supported by the large emission reduction and overall footprint by the use of simple design tools and readily available materials on the market. We've described how reducing greenhouse gas emissions from the construction industry is an urgent necessity, and even small reductions will have a great impact on overall emissions. Mitigation strategies that we're focused on are in the building materials space, in particular the ECO2 found in all common materials, that now, through years of innovation, are seeing more viable alternatives available on the market. By the numbers, here are some summary global statistics and what they mean for greenhouse gas emissions from the sector. Rapidly developing nations now represent 60% of the global construction sector, led by China and followed closely by India. Petroleum and gas-based energy imports account for the main greenhouse gas emissions of the sector. Embodied CO2 in construction materials is dominated by cement and the key input clinker. Innovations in all forms of construction materials and techniques are gaining popularity and commercial application. Positive trends in usage of alternative materials are taking place in Europe, North America, and parts of China. And if the 2050 targets of a decarbonised economy are to be achieved, for example, the legally binding UK target of an 80% reduction in greenhouse gas emissions by this date, the construction sector must be a significant part of the solution. Thank you everyone for your time, and we're happy to take any questions you have.